Hi everyone. In this video I am doing question 19 off the diode worksheet, and I will draw this circuit for you here. So I've got two resistors, I have a diode. I want to know the voltage at this point, between that point and ground. I want to know the current through the diode. So the question is to find this VO and ID, and we're told that there is 8 volts here. So the way to think about that, you can imagine that there is an 8-volt supply like this between here and ground. Okay, so you can picture it like that, but the book likes to shortcut it by just saying, okay, there's 8 volts there. All right. So when we're thinking about this, we're going to need some resistor values. So let me add those in. I've got, and I'll give this resistor a name, R1, and this one R2, just so I can write a formula. And so this is 1.2 kilo ohms for R1 and 4.7, that's a 4.7 kilo ohms for R2. So the first thing we want to think about is the diode going to be forward or reverse biased? Because this plus sign falls on this anode side of the diode, we know the diode is forward biased, and we know there's going to be a 0.7 volt drop here. Okay, now there's a couple of ways that we can think about finding VO. And so you have to have a bit of a strategy here. And so you can see that there's two resistors in series in this circuit. Whatever voltage is not dropped across the diode is split between those two resistors. So what I'm going to find, if I label that point A and this point B, I'm going to find VAB. Okay, so I know that VAB is going to be the 8 volts minus the drop across the diode equals 7.3 volts. Okay, so that's the voltage that is across the two resistors. So there's two ways I could do this. I could find the voltage across R1 and subtract it from 8 volts. That would give me VO. Or I could find the voltage across R2 and add it to the diode drop, and that would give me VO. So I'm going to do the second method, and I'm saying that VO is going to be equal to VR2 plus the voltage across the diode, which is the 0.7 volts, right? So you know that this is 0.7 volts. But VR2 you don't know yet. So VR2 we have to find. VR2 can be found from a voltage divider that splits VAB across R1 and R2. So remember, voltage divider says that this voltage VAB, if it's across R2, it's going to be VAB times R2 divided by the total resistance, which is R1 plus R2. Okay, so that is going to be 7.3 volts times 4.7 kilo ohms over 1.2 kilo ohms plus 4.7 kilo ohms, and that is going to equal, I didn't calculate that out on my paper, so I'm going to punch that into my calculator right now. I've got 7.3 times 4.7 divided by the total. So you have to either add those up beforehand or use the bracket function on your calculator, but that is going to be 5.9 kilo ohms. And I get 5.815 volts. Okay, is that VR2? So I know, if I go up to the top of my page here, VO is VR2 plus the 0.7 volts of VD. That's going to be 5.815 volts plus 0.7 volts, which is equal to, that is equal to 6.515 volts, and I might round that to 6.52 volts. Okay. The other thing we wanted to know was the current through the diode. Remember that this is a series circuit, so the current is the same in this whole series circuit. So we can't find the current through the diode by looking at the diode. We have to look at the resistor. So I could say that this current is going to be VR2 divided by R2, since I know what VR2 is. So that's going to be my 5.81 volts, 5.815 volts divided by my 4.7 kilo ohms, and that is going to be equal to 1.24 milliamps. Okay, so my answers here, I've got ID and I have VO.